Hi, I'm Fabio and welcome to the 7th module about the Python Introductory Course series. In particular, this module will be the biggest one of this series, and in this video we will study how to develop a Python app using the COVID data we have studied so far, and in particular we will see how we can apply login and unit testing in this app using Python. Looking at the libraries that we will use all the libraries that we already studied, like pandas, Altair, and so on, plus one. And this particular library called Streamlit, here you can see the official website, will allow us to develop a rudimental app using Python in a small amount of time. Streamlit is a particular library that is ideal to develop very fast an app, especially if the project is about data science. Here you can see how we can install the library. We will see next how to run the library. And here we can the website shows us how we can develop an app using this library. Particularly with a small amount of code, we can create quite nice web apps. Of course, since with this library you can create apps in a very fast manner, the cons are the fact that we cannot customize a lot our app, so that's why I would suggest to use this library only in the prototyping phase. For example, typically what I do is I develop and I study the data on Jupyter notebooks, and maybe I also develop some machine learning model using Jupyter notebooks. Then I build and I code a web prototype which enables me to present the results using a web app, a prototype. And in order to do so, I use the Streamlit library. The third step, if the client, for example, likes the prototype, is to change everything and bring it in production. For example, adapting the code I wrote into the company's softwares. That's how I suggest to use Streamlit in the second step about a project. Okay, so here you find the simplest way to install Streamlit, and of course we will install Streamlit as such as also pandas, Altair, and so on in our specific virtual environment. But to what we want to build? Well, basically the app we want to code is this one. On the left side you can see that I coded a navigation bar, a nav bar, which is a sort of table of contents with just 2 points that enables me to show you the cumulative deaths or the daily deaths. Then we have a checkbox, a flag, in which I can decide if in these graphs I want to see the normalized deaths per million people for that region, or the overall deaths. Then, for simplicity, I also attached to the navigation bar, to the nav bar, the picture about the Italian regions. In this way, if I don't remember correctly where the region is, I can look at this picture. The navigation bar is static. What changes when I click on the navigation bar parameters reflects on the right side of the web app. For example, here I'm into cumulative deaths, and in particular these deaths are normalized per million people. This is of course an Altair plot that is also interactive. For example, here I see the cumulative deaths, normalized deaths for all the 20 Italian regions. Let's look at, for example, only for Lombardy. Alright, here I'm looking only, unfortunately Altair is a little bit too simplistic here and doesn't show the year, but we are talking about 2020. Why? Because in order to normalize the death, we need to know the living population, and until today we are not able to access the data about 2021. So in fact, if I delete the normalized death check here, the app is running, and right now we are looking at, again, unfortunately Altair has bad options here and doesn't show the year, but here we see that the cumulative deaths without normalization show us refer also to 2021. That's because in this application reads online the data, so is always up to date. In fact, here we are in June of 2021, and we can access all this data. For example, again, Lombardy is here, this one, the biggest one. The same for daily deaths. For example, here we have Abruzzo, we have every region, and we can see in this graph the daily deaths. Also, as developed in the previous module, here we can select a region, and this line reflects the average deaths for this period of time, this temporal window I've selected. An interesting fact is that here automatically Altair scales the graph from -5 to 40 and not from 0. This means that some recordings here refer to negative daily deaths. This can be anomalous, and in my opinion should be at least reported. That's where logging takes place. In particular, in this web app, everything you do, in particular every data you load and you manipulate before plotting it, is scanned, and every result for this scan, for the checks we code, are stored in a log file. For example, here if we look at Trentino Alto Adige, we will see here a sort of outlier here. Something is wrong with the data, of course, and these kind of things can be properly seen in the log file. Another thing here that we don't see actually in the web application, but it's under the hood, are the unit tests. I've developed several unit tests in order to test a few components about this web app without running the entire web app. Unit tests, in fact, and running the unit tests with positive exit means that all the small functionality that I'm testing that compose the web app are working properly, at least for the tests I've implemented. Okay, so I've presented the ultimate result we want to achieve. A nav bar on the left side and the plots on the right side, and the capability to select cumulative deaths and daily deaths, and also to normalize the deaths. First thing to do after we decide how to compose the web app is to segment, to truncate, to split the web app in each single component. And this allows us to split the code into several Python files in order to give a logic on what we are doing and what we are coding. So let me show you the VS Code then. Alright, this is my VS Code. We are here in COVID app. I've already created the virtual environment. So now I have to tell Visual Studio Code to run the Python code using the virtual environment. So I click here and I select don't run this here, but enter interpret file. This one should be on scripts if I remember correctly, and that's Python. Alright, we are in VS Code. You can see that the configuration file, the settings file in VS Code tells, okay, which Python should I use? The Python file in the interpreter. Here we are talking about Windows, so we find this path here. Alright, so now we are able, in fact, if I open a new terminal here, window, you can see that it activates Visual Studio Code activates correctly the virtual environment. Fine, in fact, I can type Python and you can see everything works correctly. So let's quit and clear. Okay. Now we have to, and let me also tell you what we have in these other two folders. Here we have the data, the Italian population per region here. You can see here we have the region, the year, and the population. We use an external file because it's quite difficult to update automatically this file, because in Italy you have to download an Excel file. Also you have to code some workarounds. In order to simplify the project, we download the resource and we store it locally. With respect to the COVID deaths, instead, we will download automatically, creating a sort of API. So here we have the Italian population per region data. Unfortunately, this data refers at maximum to 2020. so we don't have the 2021 data. And because of that, we cannot compute the normalized deaths and the COVID deaths for 2021. Excuse me. Lastly, in image we find the Italian regions. Okay, because we have decided to include this picture in our web app. Our first thing we need to create is a folder in which we will store all the Python files, and the folder should be named in such a way that this will be the name of the module we are creating. For simplicity here, I call app. We are creating a web app, so that's it. I'm talking about a module, and in particular what we are doing here is creating a package, a set of different Python files that together make some sense, but using other libraries that we will not include in this video, you are also able to make this package also pip installable. So for example, you can post all this code to GitHub, make the package pip installable, and everyone that wants to replicate your project can basically pip install your library and run the web app. That's it. Okay, so we have created the Python the app folder that is empty right now. We also need to create a sort of access point where we will run the app. The access point will be outside the app, and we will call it run.py. Okay. Also, we want to probably we will use some configurations. For example, the website from which we will retrieve the COVID deaths, the data. This sort of configuration will be stored outside the package and will be named config.py. We will use a Python file to store configurations. You can also implement a configuration using YAML files, JSON, and TXT, and whatever. For simplicity here, we are using config.py. Okay. Now let's begin to code something. In my opinion, we should first code the configurations. In configuration, we will in particular select the path, the data path. This is for sure a configuration. Also, another setting would be the URL from which we will retrieve the COVID data. So let's start from this. We will code a class named config, and first we will define the input path such that this is a path. Okay, so here we have to import from pathlib import path, and here what we will store where the data is in data. Okay, the COVID URL will be COVID URL. will be the link from which we will retrieve the COVID data, would be this GitHub link. Okay, let me copy. Okay, we are basically going in the user PCM DPC project COVID-19 branch will be master, and then these are the folders and the CSV that is updated, daily updated. Okay, another thing that we will need is to optimize the regions. In particular, it's better to define here which regions we will analyze and how they are named. We will analyze all the 20 regions, and the naming is the following here. I just copy paste, you can see here. Because, for example, here sometimes the dash is not included, here maybe is positioned a dash. Defining here in the configuration file the name of the regions, we avoid this problem. Another configuration we will need refers to Altair, so let's import Altair as ALT. Is the fact that we don't want Altair to report the warning message about the maximum rows. So we tell Altair data transformers disable max rows. Okay. We shut down this warning. Okay, I think we are done with the configuration. Next, we have to load the configuration and to run the app. So let's move to the run app, to the run file, Python file. And what we will do? We import absolutely the configuration. So from config, import the config, the config class. And then we tell that, we will see in a moment what I want to do. We tell that if I run this, main if I run specifically this file, I want to call the app using these configurations. Okay, this means that the app is a class or a function that ingests the configuration and runs the Streamlit app. But we still don't have defined what and where the app is. We will store the code for the app inside the app folder. In particular, we will do from app folder here, import the app function will be a function. Okay. Now we have to finally code the app. We need to create a file here, in particular the init file. The init file, written in this way, is a Python convention and is the access point for the package, for the module we are creating. Adding the init.py to a folder tells Python to read the folder as a module. Inside the init file, we will define the app. So here we will define the app such that it ingests the config. Here we are using the typing convention, so I have to tell from config import config. Okay. And we will do something. Okay, but what we will do here? Well, we will first import the data. Import the data slash manipulate. Import slash manipulate here, right? First thing. Second, we are and the data is ready. Let's create the web app. So first thing we can create, that is the easiest one, is to create the navbar. So navbar here. And finally, the right part of the web app would be just I display the page, which will be the content itself, right? Okay, so first let's focus on how to import and manipulate the data, which is the heaviest part for this web app, because the navbar is very simple to be created using Streamlit, and instead the display page is a combination of the some Streamlit functions, quite easy then, and all the Altair plots we already coded in the previous course. So we are good with that. Then the heaviest part is to import and manipulate the data, because we have to synthesize in an app way all the manipulation we were doing in the previous Jupyter notebooks. So here we have to import and manipulate the data. This means we have to load the data. Let's create a new block of code that we will call loader.py, and in the loader file we will store all the functions that allow us to import the data and manipulate it. Let's start from, for example, how to download the data, right? In particular, we have to download it from the internet, and in order to do so, we have to refer to this library, the request libraries, that it's already part of the standard Python package. We then code a function named download COVID data, and what do I need for downloading the COVID data? Well, the information about the URL, for example, which is stored inside the configuration. This means that this configuration class is read by the run file. It's passed through the app, and from the app function here we will call download, for example, download COVID data, passing through the configuration. So here again config, that for is config, config. In fact, here I will tell import, from config import config. What we will return? Well, we will use pandas, so let's import pandas. Here we will import pandas, and also we can tell to the reader that the output of a download COVID data will be a pandas data frame. That's good. Okay. Now let's begin to write this COVID date, this function. One thing to notice is the fact that we are not certain about the fact that the link is correct and the link is working, in the sense that we are able to actually download the COVID data. So what we are doing in this function is to try to download the COVID data from that link. And if something is wrong, we should be able to handle the exceptions. What is going wrong? So here we type the try, we try, and we will do something except in order to handle the exceptions. We will make a request, in particular a get request, to which link? The config.covid URL, and eventually we allow redirects. If the link is correct, we don't no redirects should be needed. Okay. R will store all the data that I receive when I send our get request to COVID URL. Now I have to decode the data. So I have the URL, I define a new variable, URL data, such that I retrieve the content about the response, and I decoded in UTF-8, so using standard characters for simplicity. Then I have to take this data and finally store it in a pandas data frame. Here there's something a little bit tricky and that not very relevant for what we do. That's why I will tell you that I simply import from IO input output. I import this string AO function that basically formats correctly this URL data. So the data frame will be a pandas data frame in which we will have that not a pandas data frame, but we read a CSV, and finally we cast correctly the data, URL data, using the string AO URL data. The separator will be the comma, and I already know that, and we already know from the previous courses that the first column refers to the date. So we can already tell to parse dates 0. This means that the 0th column, which is the first one, basically, should be interpreted as a datetime column. If something is breaks during these 3 lines of code, for example, here I get a bad response. Here the content of this response cannot be decoded, or the content that I get can be written as a CSV. Python falls into the exception. What we can do here, well, we can say that the return will be none. we tell this function to return none. That's quite good, but now I want to test this small function that I wrote. For example, maybe I missed something, but how can I do this? How can I test this function if, for example, these configurations came actually from the configuration file, passed through the run and the init file? How can I do that? Well, for example, I can run the loader.py file itself, and here, for example, tell download the COVID data using these parameters, etc., etc. And for example, print the output here. Okay, but maybe in the next 10 minutes I will add other two functions here, and this print makes no sense anymore. So I need a place here where I can run small pieces of code and test them, their functionalities, without destroying, without interfere with the whole app that we are going to create. That's where unit test can be used. So we create excuse me, a folder called tests, and here we will save some Python files. In particular, here what we are going to test and would be we test the data loaders, and the file in which we will test will be named test data loaders. The test word is crucial because we will see in a minute that allows Visual Studio Code to read this Python file not as a whatever file, but a file that contains unit tests. The library used, one of the libraries that can be used in order to implement unit tests is the unit test library, written in this way: unit tests, and is a standard Python library, so we don't need to pip install it. Also, of course, for our test we will use pandas, of course, because we will deal with the data frames. How we can implement the tests? We create a class called test data loader, for example, that inherits the functionality from another method, which will be the unit test.test case. Okay, here all the functions we will wrote would be functions that test each component of our web app. For example, here we can try to download one COVID app. So let me type self, because we are inside a class. So what we want to test? We want to test the fact that we download 1 day of COVID data. We will test then the download COVID data function. let's import. So from app.loader we will import. You will see in a minute why we will use the parentheses. We use download COVID data. Okay. We will, for simplicity, we will also import the from config dot import config in order to inherit the structure of the configuration class, but in our test we will modify it. In fact, here we will load config equal config. We will load separately the configurations, and finally here, excuse me, all right, and finally we will say date. Let's load the COVID data only about this date, for example 2020 December 31. The COVID in the config COVID URL will be a composition of this one. You can see here we access these GitHub folders, and in particular this specific CSV file that refers to only one day. We are retrieving the COVID deaths about the last day of 2020. Then we can finally run our function using the new configurations. And about this data, what we would expect? Well, we expect this data to have a length. Which length? Let's see. If I excuse me, because I want to show you exactly what we find in this CSV file. Okay, let me show you. Okay, this is what we would see here for 2020 12/31. You can see here that the date is only the last day of the year, and the fact that we have the information for each region. Okay, now let's go back here. We download the COVID data and we tell I assert equal this surface. I can type self assert because this is a property of the test case that I inherited, that the data dot shape here of this data frame should be equal to a tuple in which the rows are 20, the number of regions, so the len of config.regions, and the columns, maybe I write it right in this way, and and the columns will be, let's keep it for now, for example here we can do this trick for now, because you will see next what I want to do. So here we are telling I expect this tuple that tells me the number of rows and the number of columns should be equal to the number of regions for the rows and the numbers of columns itself. So here we are testing only the rows for now. Then I have to tell Visual Studio Code to find the tests inside my project here. So I access the panel and I type here tests. Python discover tests. Okay, discover. No tests framework configured. Okay, enable and configure tests. Which test framework I'm using? Unit test. Okay. Which directory contains the tests? I can tell tests or the root directory and it will scan the entire project. Let's tell tests, for example. How the Python files that refer to tests are named? Using tests as the first letter. So here, tests. You can see the icon about testing and the fact that here, if I go here, is scanning. Visual Studio Code is scanning for tests. And what it tells me, okay, this class refers to tests, to some tests. And I can run each test separately or by typing here, by clicking here, run test, I can run all the tests inside the class. You can see here the hierarchy. Inside this file, I have this class that contains these tests. Let's run the entire, which means only this this test, and let's see what it does. All right, here you can see that the test has been run, but the test fails because of an error, an attribute error. Non-type object has no attribute shape, probably because of this, because of data, right? For example, I can also do some print in order to see what is happening here. I run the test. Let's see what is wrong. None is the output. Okay, so something is wrong here, or is wrong in the code. Let's see what can be wrong. We move to loader. What we have made wrong? The fact that we never return the data frame. So here, if everything is going good, we have to return the data frame. We have made a mistake, and thanks to the test, we are probably solving it. Let's run again the test. Again, some error here. Tuples differ here. Assertion error. It tells me there's an error here because the rows are 21 and not 20. Let's look at why this happens. If I remember correctly, I also print the data, right? Okay. Here I read 21. Let's see, in Italian here we have the denominazione regione. Oh, okay, I get it. And I can show you why looking at the Chrome. Another point is here the fact that we have this Provincia Autonoma Bolzano and Provincia Autonoma Trento, which are not coded as a region, because the two are part of one unique region, the Trentino Alto Adige region. So we have to fix this problem, and then we will finally find that the rows will be 20. Let's move here and let's fix this other problem. If we import correctly the data frame, we can now start to modify it. The first thing we have to solve is the Provincia Autonoma problem, in which a region is split into parts. We have in this way to re-encode it in only one part. In order to do so, let's do two things. First, re-encode the columns, rename the columns in English, but only the ones about we care. Second, we fix the region's name. So let's first rename the columns. So columns equal we rename the columns. We rename the date, which in Italian is data. We rename it in date. We rename the denominazione regione. Denominazione regione means region. Finally, deceduti means deaths. That's it. I rename it in place. So I tell to overwrite. Here we can, for example, put some comments like rename relevant columns, translating them in English. Perfect. Another thing we have to do is to fix regions names. We have the autonomous province to region, and this will be a dictionary that tells us that, let me just copy paste this way, that the Provincia Autonoma Bolzano and the Provincia Autonoma Trento should be encoded as Trentino Alto Adige. Okay? Finally, we have to do the replacement just by telling data frame replace to replace yes. What we want to, first of all, we want to replace in place. We want to replace in place. Second, we have to replace the fact that region. So we look at the region and we want to replace inside of the column region this thing. So we are telling that looking at the region column, you have to replace this and this with this and this. That's it. Okay, that's fine. But now we have still 21 rows, but 2 of them have the same region. Since we care about only the dates and the date, we have to group by the date and the region and to sum up the dates. In this way, we sum the dates about these 2 provinces. It's simple to do. We tell that the data frame will be the result of a group by, in which we will group only by date and region. We will compute, and the column dates will be summed. Finally, I'll also reset the index in order to keep date and region as columns and not multi-index. Now let's try again this test and see if it's working. If it's working, yeah, it's working. We can finally, you can see here 0 from 19 means 20 regions. We have date, region, dates. Since we are using the group by, we already selected only these 3 columns, the only relevant columns we care about. Okay, we can delete this. We have built successfully our first test, the unit test. But I want to test some more, and I show you, for example, we will test only this function for just for demonstration, and I want to show you this one, this other other 2 tests that I've made. For the other, download from COVID data from an invalid link. The invalid link is Google. I run download COVID data function, and since the function should not be able to load here the data from google.com and decode it in a CSV file and store that data in a data frame, I expect this to return none. In fact, here I tell assert is none. Another thing I can do here, test download from an invalid link. Since here the link exists, I get a response from Google, but the content of the response cannot be coded as a CSV file and cannot be stored in a data frame. Here the things are worse. This link does not exist. It's just random typing on the keyboard. So again, I expect this function to return none. Let's rerun all the tests. Let's see if okay, everything is working. Perfect. This function is working. We have just to complete one thing, which is the fact that if you see here, when I was printing the result of a test, here you can see the date but also the time. We don't care about the time, so let's keep only the dates. Keep only the dates. Very simple to do. We type df data frame date is equal to df data dot date time normalize. Normalize means normalize the time. Very simple, and we are finally able to download all the COVID data up to today. There's a caveat here, because we did not implemented the web app yet, but there's a problem. Every time in Streamlit, every time I make a change in the Streamlit app, for example, I check a checkbox, I change something, some properties about the Streamlit app, the Streamlit app reloads again. You see why it can be used only for prototyping. But if, when I loaded the app, I also download the data, this means that I download the data every time I make a change to the web app. This makes no sense. That's why Streamlit implemented a sort of cache, and the output of a function can be cached until the entire web app is closed and opened again. In order to do so, I just have to add this Streamlit. I import Streamlit as st, and I add this Streamlit cache. Here I also refer to two parameters, two options. The fact that I want to suppress the warnings, that sometimes can happen. I want to allow output mutation, because maybe in reloading I have problems with the downloading the data, and I get two outputs, so that's why it cannot be cached completely. This change makes the Streamlit app a lot faster. Perfect. Okay, now we have to do two things here. We have to, this data refers to cumulative data, cumulative deaths. We have to compute the daily deaths, and also we have to code a function that normalizes the deaths per million people. These are the other two manipulations we have to make about the data. Let's begin with the function that from cumulative data returns us the daily deaths. Here I just type this. So data cumulative to daily deaths function, we cache the output, data will be a data frame here. Frame, and the output will be a pandas data frame. First thing to do, here we have to quite a lot of things, and you will see in a minute. First of all, we have to compute the cumulative deaths per region, which means okay, I also copy the comments. Compute the daily deaths from cumulative day. So the cumulative deaths per region are the result of a pivot table in which the data is the data, the index will be the date, the columns will be the region. So we will not have a column named region anymore, but we have 20 columns. Each of them will have the name of one of the 20 regions. Values will be the deaths. If we look at this cumulative, this output, we will see that we have to make some adjustments then. And finally, the aggregation function will be sum, but we should this should make any difference. Okay, then the regions. Which are the regions here? Since the index is the date, we will have 20 columns, the 20 regions. So let's store the regions here as the cumulative, that's per region columns. Now we have to compute a fake row to add as the first one, the first row. So fake row will be a pandas data frame in which the data is coded as region 0, in which 4 are in region. Okay, this is the data. So for each regions, for each region we type that we have 0 deaths. Second index, we have to take the minimum date minus 1 date. Why we are computing this fake row? Because the fake row will be on top of our data frame, and when we computed the delta between the previous cumulative deaths and the next cumulative deaths, for the first row the result will be none, because there's no previous. In this way we don't discard any valid rows, and we will next discard the fake row for which we cannot compute the daily death, because we don't have the delta. We cannot compute the delta without a before. We have only the after. So here we have cumulative the deaths. We take the index, which is our date. We compute the minimum, and then we subtract 1 day. So PD date offset about 1 days 1. Finally, this fake row should be on top of our cumulative deaths per region, the valid data. So here we have that cumulative deaths per region would be a concatenation of fake row. We care about the order and the cumulative deaths per region here. We can also specify that we want to concat about the rows. Just tell me. We don't have to tell in this concatenation to ignore the index, otherwise we will discard the date thing for which we are doing this step. Finally, now that we have this fake row, we can compute the difference about the cumulative values and define the incremental deaths per region, also called daily deaths. So it would be cumulative daily deaths per region. We do a difference. If we type diff for an entire data frame, and we specify periods equal to 1, and also the difference would be axis 0. It means that we are computing the difference. We take each column of the data frame and we compute the difference by row, which are the columns, all the 20 regions. That's very, very good. Okay, now we drop the NA, and we expect only one NA that refers to the fake row. So incremental deaths per region, drop NA, axis 0. How? All in place equals to true. And this way we discarded the first row. Want to see what happens here? Okay, for example, here we can do a return incremental deaths per region. We'll see in a minute what we do. We can use the test loader here to run something we would like. For example, here let's call it a test something. This is temporary, just to show you how you can also use tests in order to run the code, run chunks of code. For example, I want config as the standard config. Okay. I don't change the COVID URL. I want to actually download that data, and I want to print the data. This is actually not a test, right? Because I'm testing nothing. but the structure that Visual Studio Code has allows me to do this and to run separately different chunks of code. Of course, this and what we will write next should be deleted because it's not actually a test. But for now, we can use it, right? So here we import also this, and we will run instead of printing the data itself, we will run the cumulative daily deaths just by giving data. Okay, it discovered the test. Okay, it has discovered one test. So here we clear the output and we run test something. Okay, there's an error, a typing error. It tells me one error. No. Data. It tells me about the data. If I'm going here, data. Data is here. What's the problem here? Key error data. Oh, gives me some problem with the cache because we didn't run the Python app for now. The Streamlit app. So probably that's why. Let's see. Non-type, running the root. Still the same problem here. Let me test this. Is this running correctly? Yes. So we have a problem here. Let's break the things and run and try to debug the code. In this way you can see how to really debug. For example, here I can comment everything. So I can return cumulative daily deaths. Let's see if this returns me the problem anyway. Non-type tells me. Caching cache key not founded. Key error data. It's quite strange. Is this the problem? The data? Oh, this one probably. Let's see. Okay. I'm good, right? That's because I didn't run all the tests. And here you can see in these two tests, I'm testing the code to break. But that's not enough. I also have to test that the code is working. which is this one. Here I can type 3 right now, because we know that we have only 3 columns: the date, the dates, and the region. So if I run everything now, should be working. I can still keep the cache, doesn't make any difference. Okay. Okay, I want to look at the output here. So I would like to test this. Show me, show me. Oh, it tells me the function. Whoopsie. Gives me the function. Let's try to t, and we print t. Okay, let's rerun. The only boring stuff about testing is the fact that the Visual Studio Code has to reload again and again and again the tests in order to find them every time you make a change. Is testing... It's quite strange.